All right, just to review, yesterday we went over this unit circle. You will have a blank unit circle on your quiz. It will be worth 32 points of your quiz.
That's what's up.
Okay?
Easy A.
And all you have to do is fill in all the degrees. That's 16 points. And then you will fill in all of the radian measurements that correspond with those. That is another 16 points. Yes?
You just take the degrees and you convert those to radians.
If that's what you want to do, you can do it that way.
180
Or you can use the counting method and be done in 2 minutes.
What did the counting method mean?
Well, yeah, what's the counting method?
Counting method that we did yesterday. So we said we knew that the two things that we're going to memorize is that 45 degrees is pi over 4. So then I went pi over 4, 2 pi over 4, simplified, 3 pi over 4, 4 pi over 4, simplified, 5 pi over 4, 6 pi over 4, simplified, 7 pi over 4, 8 pi over 4, counted. And then we memorized that 30 degrees is pi over 6, so I have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay? That way is very fast. Yes.
How many points is this quiz out of?
I'll have to double check, but more than 32.
I was gonna say, if I can get this down, I'll get that.
But that's a big part of it. Okay. All right. So now we are going to use that. So reference angle. So in order to find a reference angle, you draw a perpendicular line from the angle to the x-axis. Right? So if I want to find the reference angle of 320 degrees, all right? So I look at my little xy axes here. Where will 320 degrees be? What quadrant? Does everybody remember the quadrant numbers, by the way?
It's going to be at 3.
They go 1, 2,
Oh.
3,
Wow.
4.
Should be quadrant 4.
Quadrant 4, okay? Because I have to go 90, this is 180, this is 270, and then how much more past to get to 320?
About 40.
It'll be 40 from here, but 270 plus 50 gets me to 320. So this is 50, this is 40. All right, follow that? All right, so that's where my angle is going to be. Now, to find the angle, it says draw the perpendicular line from the angle to the x-axis. Nice. Okay, so what's the reference angle for 320 degrees? It's going to be the angle that touches the x-axis in here by the origin. And it's got to be inside your triangle. So what is it going to be? 40, but it's down, negative 40. These are coterminal angles because they both end at the same place, right? But for reference angles, we want ones that are less than 90 degrees because they're easier to work with.
So you could have just subtracted 360 and just be done with the whole lot.
That'll work too. It's not going to help you out in part B here because this one is in radians. Yes.
I really don't understand how you got that negative 40. Like, I get how you drew the line.
Okay. When I wanted to get to 320, I went 90, and then another 90, so I'm at 180. And then I'm at another 90, which is at 270. And then to get to 320, I had to go another 50. So the blue is 320 degrees. But I don't want to work with that one. I would rather work with an angle that is less than 90 degrees. Right? So we're going to use its reference angle, which is a coterminal angle that's less than 90 degrees. Right? So how many more degrees did I have to go in order to get all the way around? 40. So I'm using that one inside this triangle.
So it's basically like what's left.
Correct.
Got it.
Okay.
And then how come it's negative?
Because to get from 0 backwards, we had to go in the negative direction.
Okay, so basically find how much is left and then make it negative.
Yeah, and whether this is positive or negative, I don't really care. I'm more interested that you recognize that this was 40. Okay. All right, so find the reference angle for negative 5 pi over 6.
Multiply by 180 over pi.
That's a good way to start, is just to turn it into degrees because you guys are already good at that.
And then subtract 360.
But then whatever you come back with for your reference angle, then you turn it back into radians, because if the problem starts in radians, you need to end in radians. If it starts in degrees, you need to end in degrees. Okay, so when I multiply this one out, the pi's cancel.
6 and 8, 1 8.
How many 6's are there in 180?
35? No,
30. So negative 5 times 30. So this is negative 150. Okay, so I have to go backwards. So I'm going to go 90. Then how much more?
60.
60 that way. So that's where my angle is going to be. This is 60. So my reference angle is going to be what? I put my perpendicular in. How much is left here? 30. Okay, but they don't want it in degrees. They want it in radians. Because I started in radians, I need to end in 80 radians. So now I go back.
30 times pi over 180.
So I'm going to get 30 pi over 180. Simplifies to
6.
pi over 6. Okay, now finally, this is why these problems here are why these reference angles are so important, right? This right here is what you need for the trig part in calculus, or the trig part next year in pre-calculus, and you're going to be doing this stuff a lot with calculus, right? The reference angles are good. You're going to notice that all of these are going to end with, they're going to give you reference angles that are the most important angles in trig, which are 30, 60, 90, and 45. That's it. That's what all of these are going to end on. All right, so let's start with one that's a degree first. We'll come back to this radian one because you guys aren't as good at those. All right. I want to find the tangent of 315. All right, and I don't want to use my calculator to do so.
So wouldn't it be
Where will 315 get me to? 90, 180, 270. How much more do I need to
A
go?
little bit. 30, 45 degrees.
45 more. So when I put in my reference angle, so I get my little triangle here, what will this angle be?
45.
45. What will this one be?
45.
So I have a 45, 45, 90. Now, those have preset ratios on their sides. What are they in? Okay, so let's pick easy numbers for those. Let's let this be 1, 1, and then what would this one be?
Square root of 2.
Square root of 2. All right, now we're looking at tangent of this, and we're going with this reference angle. It's going to give me the same answer as when I had 315. All right, now be careful. This one is to the right, right? So it's positive. This one is down. It's negative. The hypotenuse represents a distance. It's always positive. All right? What is tangent for us in terms of adjacents, hypotenuses, and opposites?
Opposite over adjacent.
All right, so this is opposite over adjacent. And this is the angle that I'm supposed to be referring to. What's its opposite?
-1.
What's its adjacent?
1.
So what is the tangent of 315?
-1.
That's it? What?
That's it.
How'd you get the angle?
It's a reference angle because I went 315, right? But rather than use the 315, we used a reference angle. To find the angle, you draw the perpendicular line from the angle to the x-axis. So that's what I did. I drew this line right here. And I got my 45, 45, 90 triangle, which always has the ratio of 1, 1, square root of 2. Right? And then we just had to assess for the negatives. Right? Anything that's to the left will be negative. Anything that's down will be negative. If it's a hypotenuse, always positive.
No. 30, 60 ones.
Yeah, let's do a 30, 60, 91. I think this one will work out that way.
always equal -1? Because I know we just made the sides like.
The tangent of 315 will always be -1.
Because I know we just made the sides like we just picked numbers.
Right. Well, we
We
picked
do.
the easy
It's the
ones,
same.
right?
Yeah.
If I would have, let's say instead of 1, we selected 2, then I would have had 2, -2, and then what would this one have been? 2 square root of 2. So then what's this now? My angle is still 45. What's the opposite? What's its adjacent? What's that? So I just picked the smallest things I could find. All right, now, cosine of 210. What quadrant is that going to end up in? Third one. So 90. Another 90 gets me 180. How many more to get me to 210? 30. So this is 30.
So next year,
Okay, now, what's the ratio on 30, 60, 90 triangles?
X. 2x and
Okay.
x radical.
So let's pick nice things. Let's let my short side be 1. What's the hypotenuse going to be?
1.
2. What's the long leg going to be?
Long radical 3.
Okay, now, are any of these things negative?
Yes.
Oh, the negative 1.
Why is the 1 negative? It went down. Anything else?
Radical 3.
Why? Because it's to the left. How about the 2? Hypotenuses are always positive. All right, now, cosine, what is that in terms of opposites and stuff? Close. Adjacent over hypotenuse. What's this angle's adjacent?
Negative.
What's its hypotenuse? So the cosine of 210 is negative radical 3 over 2. Sine of negative 60 degrees, where is that going to be? First quadrant, second quadrant?
Second.
Fourth. Fourth, okay? Because we have to go, because it's negative, we have to go in the opposite direction. So I have to go this way, 60 degrees. There's my right angle. This one's got to be 30. It's a 30, 60, 90. This one's my short side. Let's let it equal 1. What will the hypotenuse be? What will the long leg be? Square root of 3. So are any of these things negative? Is the 1? Nope. How about the 2? Nope. Okay, what is sine in terms of opposites and whatnot? Opposite over hypotenuse. So with my reference angle, what's the opposite? What's the hypotenuse? That's the sine of negative 60.
What would you do for the number f? I mean, like,
We'll come back to that one last. Let's do the last of the easy ones with the degrees first. So 135 degrees, where will that get me? Yep, because it's not quite to 180. How far away from 180 is it? That's convenient. So this is 45, 45, 90. How are the, what should I let the legs be? 1, 1, square root of 2. Are any of these things negative? Which one? This one, because it's to the left. The up one has to be positive because it's up. Okay? All right. What is sine for us? Opposite over hypotenuse. What is my reference angle's opposite? 1. What is its hypotenuse? Can I leave it that way? How do I fix it? I'll say I'm going to get radical 2 over 2. That is the sine of that angle. Kind of see how these work? And they always come out to be, I'm always going to give you 30, 60, 90s and 45, 45, 90s because those are the most important. Okay, now this one. This one's in radians, but we could easily turn it into degrees, right?
180 over 80.
Multiply by 180 over pi.
Okay. Now if I do that, the pi's cancel. 4 goes into 180,
45 times.
so 45 times 5.
91 fifth. No, 135. No,
More than that.
I'm thinking 200.
It's going to be 200 and 225. Where will that put me?
Second quadrant.
Not in second. Third quadrant. So 90. Another 90. So I'm 180. And then how much past 180 do I have to do to get to 225?
45.
So I have a 45, 45, 90. What should I use for my legs?
1.
Hypotenuse?
32.
Any of these negative?
The 1.
Both of the ones. Because one's to the left and one's down. Okay, so here's my reference angle. I want cosine, which is adjacent over hypotenuse. So the adjacent to this angle, negative 1, and the hypotenuse? Can I leave it that way?
No.
So I have to fix it. So I'm going to get negative square root of 2 over 2. That is the cosine of that angle. It just has the added step because you have to turn it into degrees. Yes.
Now, this before like was 180 over, what was pi over 180 as opposed to 180 over pi?
When you want to turn it from radians into degrees, you go 180 over pi. If you're turning it from degrees to radians, you flip it. All right, and then my last one over here, I want to turn 5 pi over 3 into degrees. So what do I multiply by?
180 over 5.
Pi's cancel. 3 goes into 180. 60 times 5 is? No, not in America. 300. Okay, so I want the tangent of 300 degrees. Where will 300 degrees get me?
4 quadrant.
Okay, so how far past the
2
two?
degrees.
So it's going to be 60 away from here, right? This is 30. So what should I use for my short leg?
1,
Hypotenuse?
2,
Long leg?
3.
Negative, oh, just kidding.
You're right, it is negative because it's down. Okay, so tangent is
Opposite over hypotenuse.
opposite over
No, adjacent.
adjacent. What is this angle's opposite?
30 for negative 3.
Not an angle, it's always a side. Opposite of this angle is that side.
Oh, okay.
Over hypotenuse?
2 adjacent. Has to be over adjacent.
Oh, you're right, I just did sine. This is negative square root of 3 over adjacent, 1.
And you don't need to do the whole radical 3 thing, like,
Only if you have a radical in the denominator do you need to fix it.
So the coterminal angle is always when you hit left. Is what we're looking
Right, you want the one that, you want the triangle that is touching the x-axis.
for. Okay.
Right.
more after you're done.
What's that?
Can you want more after you're done?
Yeah, because you're gonna have plenty of time to work on your homework, so you can skip right to this section if you want. This is the most important section, because you're gonna be doing this a lot next year.
Is it a worksheet or do you?
I don't believe so. Okay, kind of? All right, let's see where we're at. I think that's, okay, so we are doing page 780, 25 through 27 all. That's only 3 problems. And then 36 through 58 even.